In this video, we're going to look at how to graph parabolas without making a table. So you could take a moment to press pause and copy down everything you see, or just do so quickly while you listen to me introduce it. So a parabola is this U shape on a graph, or the upside down U shape on a graph. Okay, parabolas are perfectly symmetrical. Okay, and they're when we have an x squared term in our expression, when our expression is called quadratic. Now, to help us make sense of this, we thought of two different scenarios in class. We thought of someone bungee jumping, going down and then coming back up, or we thought of someone tossing a water balloon, going up and coming back down. Okay, so we use those two general ideas to help us picture what's going on in a parabola and understand what we need and why we need it to graph parabolas without making a table. So the first thing we need are the x-intercepts. Okay, that means where does our parabola cross the x-axis? Where is our bungee jumper on the bridge, or where is our water balloon on the ground? We want to know where we start and where we end, where the water balloon starts and where it lands. Okay, that's what the x-intercepts are. Okay, where our parabola crosses the x-axis. Now we want to know this vertex. Okay, that's a turnaround point. Okay, how high does a water balloon go? Okay, how low does our bungee jumper go? Now, the nice thing about this vertex is it's always halfway in between our x-intercepts. Okay, that makes sense. When we toss up a water balloon, it's going to go up and it's going to come back down. Okay, so the vertex, the highest point, is just halfway in between. And then the last thing we need is the y-intercept. Okay, where does our parabola cross the y-axis? All right, so let's get started with an example. Okay, so we want to do we want to graph y equals x squared minus 6x plus 8. Okay, so take a moment, press pause, set up a graph, copy the equation. Now we know immediately this is going to be a parabola because we see this x squared term. We see that this is a quadratic expression because we have that x squared term. So we don't think in terms of slope or growth and y-intercept. Okay, we have to go through our parabola, or what we need for a parabola. Okay, so again, the first thing we need are the x-intercepts. Okay, where is this bungee jumper going to be on the bridge, or where is this water balloon going to be on the ground? So we say we want x squared minus 6x plus 8 to equal 0. And the 0 represents the ground, or the bridge. Okay, we want it to be on the ground or on the bridge, so we let it equal to 0. Because that's what our x-intercepts are. They're when y equals 0. So this is where we kind of go through and use the process of the zero product property. Okay, we don't know how to solve this any other way than factoring it and using the zero product property. And once we have a product that equals 0, we know that either one of the factors equals 0. So let's first factor this expression. Now this is something we're good at doing, so we make our generic rectangle and our diamond problem right away. Okay, we know x squared is in the bottom left, and we know 8's in the upper right. Okay, we multiply x squared times 8 is 8x squared, and negative 6x goes on the bottom. So we want two numbers that multiply to 8x squared. Remember, these two have to multiply to 8x squared, and these two have to combine to give us our negative 6x. By now we're good at this, so this is negative 4x and negative 2x. We fill these back in the table. We fill in the outside. Okay, so again, this is something we're good at doing. That's why I'm going through it quickly. We have x minus 2 times x minus 4. Okay, so x minus 2 times x minus 4 equals our expression x squared minus 6x plus 8. And this still equals 0. Now the reason why we needed to factor is now we have a product. We're multiplying two expressions, or really two numbers together. We're doing x minus 2 times x minus 4. And when we multiply these two numbers together, the result is 0. Now we know that if we multiply two numbers together and the answer is 0, that means either one of the numbers or either one of the factors has to equal 0. That's what the zero product property is. Okay, so we're multiplying x minus 2, which represents one number, and x minus 4, which represents another number. Their product is 0, so that means x minus 2 has to equal 0, or x minus 4 has to equal 0. Now, just because we have algebra doesn't mean this is a confusing concept. Okay, if we're multiplying two numbers together, which we are, and the product equals 0, then our first number has to equal 0, or our second number has to equal 0. And that's really just common sense, because so the first one, well, I know 2 minus 2 is 0, so x could equal 2. I know 4 minus 4 is 0, x minus 4 is 0, so that means x equals 4. Okay, so when x is 2, this original expression equals 0, because 2 minus 2 is 0. 0 times anything equals 0. Or when x equals 4, 4 minus 4 is 0, and this 0 times anything equals 0. So these are the two x-intercepts. Okay, meaning our bungee jumper jumped off the bridge at x equals 2, so we plot that point, and he got back up to the bridge when x equals 4. Okay, so we plot that point. So we just plot the two x-intercepts once we have them. This is where he jumped off the bridge, this is where he landed back up on the bridge. Okay, so that's how we find the x-intercepts. Now that seems like it took a lot of work, but again, factoring is something we're good at doing, and the zero product property is a very simple idea to understand. We have the product that equals 0, so either one of the factors has to equal 0. So now let's go on to finding the vertex. Okay, now we know the vertex is halfway between the x-intercepts, because that's where the bungee jumper, or that's where the water balloon is going to turn around and come back up or go back down. So we look at our graph and we see what's halfway between our x-intercepts. Okay, well that's right here. So we just draw a little dotted line to show us this is where the vertex is going to be. Okay, then we think, well, where is this? Okay, what x value is this? Well, this is x equals 2, this is x equals 4, this is 3. Okay, this is when x equals 3 is where our vertex is. Okay, so now we want to know when x equals 3, okay, where is this bungee jumper turning around? Okay, how far down does this bungee jumper go? Now, in order to figure this out, we have to substitute x equals 3 into the rule, into the equation. Okay, so our equation is still y equals x squared minus 6x plus 8. Okay, so we know x equals 3, so basically we want to know if x equals 3, what's y? So we get y equals 3 squared minus 6 times 3 plus 8. And again, this is something we've been doing since the beginning of the year. We're just substituting x equals 3. So substituting 3 in for x, we want to know what's the output when we input 3 into our rule. Okay, so 3 squared is 9. 9 minus 18 is negative 9, plus 8 is negative 1. Okay, so when x equals 3, y equals negative 1. That means the bungee jumper goes down, or is down 1 meter at this turnaround point. He turns around 1 meter below the bridge. Okay, so this is the point 3, negative 1 that we plot. And this is the vertex. Okay, so we plot this point. Again, when he's halfway in between, when this bungee jumper is halfway in between, he's at negative 1. Okay, so that's our vertex. And the last one is our y-intercept. Now, when we talked about lines, the y-intercept was really the starting amount. But in this context, when we have parabolas and we're thinking in terms of a water balloon toss and a bungee jumper, the y-intercept doesn't have the same meaning. Now, the reason why we only want to find the y-intercept is because it's actually very easy to find. The y-intercept is always the constant in the rule. Okay, it's meaning it's a number that's by itself. It's a number that's not x or x squared. So we look in our rule. So we have y equals x squared. And you wouldn't rewrite this, but I'm just rewriting this so we can see it right here. Minus 6x plus 8. We look at what's the constant. Well, our constant is 8, so our y-intercept is 8. Okay, very easy, just like it was when we had a line. The y-intercept was just a number that's by itself. The same thing's true for parabolas. So let's plot our y-intercept being 8. And now we have enough points to sketch a graph of our parabola. Now we know parabolas are symmetrical, so if we're going to start up here and come down, then we got to go back up to where it would be on this side. So we can just kind of see that if we kind of fold it over symmetrically, then we have another point down here. Again, we use this y-intercept to know that, well, parabolas have to be symmetrical. So if we go up that high before, then we have to go up that high after. And then this is how we this is how we graph a parabola using the x-intercepts, the vertex, and the y-intercepts. Again, we factor and use the zero product property to find the x-intercepts. We notice that the vertex, that turnaround point's always halfway in between our x-intercepts. And we know our y-intercept is just a constant in the rule. And once you get good at this, you're going to be able to do this very quickly. Okay, so why don't you try 2 examples on your own. So y equals the opposite of x squared plus 4x plus 5. And y equals x squared plus 7x plus 10. So press pause, try these 2, then press play when you're ready to check your work. Okay, so let's start by setting up a graph because we know we're going to be graphing. Okay, so I'm just going to work underneath my graph, and we'll come back up when we need to plot our points. So you want to factor. So we have negative x squared plus 4x plus 5. We want to know when this equals 0. When is this water balloon going to be on the ground? So we make a generic rectangle, negative x squared and 5. Multiply to negative 5x squared. Add to 4x. Again, this is factoring. We're good at this. So we have a positive 5x and a negative 1x. We fill these in. Okay, so we bring out numbers on the outside. I know negative x times x gives me negative x squared. X times 5 is 5x. Negative x times 1 is negative x. So this is x plus 1 times negative x plus 5. And this equals 0. So we have x plus 1 equals 0, which means x equals negative 1, or the opposite of x plus 5 equals 0, which means x equals 5. So these are the 2 x-intercepts. Okay, we launch the water balloon when x equals negative 1, and it lands when x equals 5. Now our vertex. Okay, now we want to find our vertex. So we go, what's halfway in between these 2 points? So we kind of just go to the middle. That's here when x equals 2. So I'm going to substitute 2 into my rule. So we have the opposite of 2 squared plus 4 times 2 plus 5. This is going to give us our y. 2 squared is 4. Make it negative negative 4. Negative 4 plus 8 is 4. Plus 5 is 9. So our vertex is the point 2, 9. Okay, I didn't do a good job setting up my graph because we have to go up pretty high. So our vertex is actually all the way up here above the 4. That's not a big deal. And our y-intercept, this is very easy. We don't have to write anything down. Our y-intercept is just 5. Okay, so now we sketch a parabola. We come up, and then we come back down. And then just like our lines, we go past the points after we try and hit them. And we put arrows on each end. Okay, this example, try and do a better job, make my graph bigger. so here's our graph. We're going to start by finding the x-intercept. Why or when is this bungee jumper on the ground? So we set it equal to 0. We factor. We know how to factor, so I'll just go right to the answer. After you factor, you get x plus 5 times x plus 2. This equals 0. So this means x plus 5 equals 0, which means x equals negative 5. Or x plus 2 equals 0, which means x equals negative 2. So the bungee jumper jumps off the bridge at negative 5. It comes back up to the bridge at negative 2. Okay, now we need the vertex. Now the vertex is halfway in between. We're in 8th grade. We understand that fractions are numbers too, and halfway in between these 2 points is simply negative 3.5. So our vertex is when x equals negative 3.5. So we substitute this into our rule, okay, just like we would with the number. So our y is going to equal negative 3.5 squared plus 7 times negative 3.5 plus 10. And we'll just type this into our calculator because I can't do this one in my head. And this gives us y equals negative 2.25. So the vertex is the point negative 3.5, negative 2.25. Okay, please don't tell me you don't know how to plot those points. Negative 2.25 is just a little bit past negative 2. So we're at our negative 3.5. We go a little bit past negative 2. So our vertex is here. Our y-intercept is just the constant in our rule, so it's at 10. Now we know because we come up this high on the right, we have to go up this high on the left. So we come down, turn around at our vertex, try and hit our points, put arrows on the ends. Okay, and that's how we graph parabolas without making a table. So for more practice, refer to the textbook or some of the other online resources.